The upper Mississippi watershed has the highest population density in Minnesota. The build-up area and the agricultural areas together cover most of the land and constitute a source of environmental pollution. About 55% of the population in Minnesota lives in the area of the Twin Cities, and the number of residents is expected to grow in the coming years. The significant threat to water bodies works in two directions: water pollution and damage to the ecological balance of the lakes, and the growing potential for floods. Our design focuses on these two variables. The main actors in this narrative are climate change and increasing population density. The response to climate change should address the increasing risk of floods and the requirements for more effective stormwater management. In addition, an increase in population density necessitates the discussion of social justice in the context of public space. According to the following diagram, there is a clear imbalance in the proportions of areas that constitute sources of pollution versus natural areas. But this map can be interpreted in terms of private versus public space. Given the fact that the population density is expected to increase, the need for public space will also increase. We see water bodies as focal points to answer those needs. When looking at Minneapolis' chain of lakes critically, it can be seen that the buffer zone around the lakes is quite narrow. So instead of thinking about the buffer as partition, we decided to think of it as mediator between the built environment and the water bodies.
The urban main road drives across the chain of lakes, which produces pollutants through insufficient buffer zone. The parking area attached to the lake has insufficient concrete pavements increase the level of runoff. The entrances are mostly simply concrete pavement without protection of vegetation zones. Recreational purposes like sports and boating occurs on the shore bank of the lake. The undamaged forest prevents erosion and runoff from urban conditions. However, the area of forest so far is minimum, especially for B'nai-Makaska. The following images show extended buffer zone. First layer is the permeable pavements within several blocks of the lake. The pavements will have connective access to the lake. The walkway and cycleway reorganized by connections. Outer buffer zones block off dense urban conditions. Inner buffer zone and human activities with natural vegetation can be filtration for other pollutants. The aquatic plants are functional as the last layer of the buffer zone.
We need a solution that will allow the buffer to expand despite the challenge of a build-up area. Using the streets as an extended buffer zone is an effective way that will constitute a gradual fusion of the territory of the water bodies with the built environment.
The series of diagrammatic sections show the existing condition and the suggestions from pavements to vegetations. The ground level collage shows layers of buffers in human scale. The private properties connect to the public area through permeable pavements, yet tree trenches and vegetations block off some views for privacy. The outer buffer distinct from pavements and vegetations. The pavements connect across the streets and buffer zone to the walkways that are extended to the lake.